This is how the universe ends. And it's already started. It doesn't begin with a bang, or a crash, or a cataclysm we'd notice. No, the end is far more subtle. In fact, some physicists believe it's happening right now, quietly, invisibly, all around us. To understand how the universe could be ending, even as we live in it, we have to dive deep into the most mind-bending science humanity has ever uncovered: quantum physics, cosmic expansion, and the death of everything. Let's start with a simple truth. The universe is expanding. This was first discovered by Edwin Hubble in the 1920s when he noticed that galaxies were moving away from us. And not just moving, they were accelerating. Space itself was stretching. That expansion is still happening, faster and faster, and no one fully knows why. Scientists call the mysterious force behind this acceleration dark energy, and it makes up nearly 70% of everything in the universe. The terrifying part, we don't know what dark energy is, only that it's pulling the universe apart. And if that expansion continues unchecked, it could lead to what's called the heat death of the universe. A slow, cold, and absolute end. In a heat death scenario, everything becomes so spread out that energy itself can no longer move. No stars, no light, no life. Just particles drifting endlessly in darkness, too far apart to interact. Over trillions of years, even black holes would evaporate via Hawking radiation, leaving nothing but cold, lifeless space. No explosions, no chaos. Just silence, forever. But that's not the only theory, and not even the scariest one. Another possibility is the Big Rip. This theory starts the same way: expansion, but in this version, the dark energy doesn't just push galaxies apart. It keeps getting stronger. So strong, in fact, that it eventually rips galaxies, stars, planets, and even atoms apart. First, galaxies would be torn from each other, then stars from their orbits. Then molecules themselves would be ripped apart. In the final moments, even the fabric of space-time would be It's the ultimate destruction, not with a whisper, but with a scream. But what if the universe doesn't end by stretching, but by collapsing? That brings us to the big crunch. Imagine this. The expansion slows, stops, and then reverses. Gravity wins. Everything in the universe begins to fall back in on itself. Galaxies collide, stars smash together, and temperatures skyrocket. Eventually, all matter and energy collapse into a single point. Just like at the beginning, some believe this could be followed by another Big Bang, starting the cycle all over again, the universe reborn. Yet, there's a newer, more unsettling theory, one that isn't based on gravity, or stars, or time itself. It comes from the quantum realm, the bizarre world of particles and probabilities. This theory is called vacuum decay, and if it's true, then the universe could be destroyed at any moment. With no warning, according to quantum field theory, our universe exists in a state of what's called a false vacuum. It seems stable, but it's not. It's like a ball resting in a shallow valley. Not the lowest possible one, just a convenient one. If that ball ever tunnels through to a deeper valley, the true vacuum, it would trigger a bubble of destruction, expanding at the speed of light. Anything it touches ceases to exist. Physics, as we know it, would be the laws that govern matter, energy, even time, go, and we'd never see it coming. And here's the mind-breaking part. This process might have already started. Somewhere in the farthest reaches of space, a vacuum bubble could be expanding right now, faster than light, and we wouldn't know until it hits us. We'd be here 1 second, and then nothing. Not even the memory of being. It's the kind of thought that makes the skin crawl. A cosmic reset button, invisible and unstoppable. So, which of these fates is most likely? Right now, the data suggests we're heading toward heat death, the slow freeze. The universe is expanding faster and faster, galaxies are drifting apart, and the stars are going out. Eventually, there won't be enough gas left to form new ones. The lights will slowly wink out, and over unimaginable timescales, the universe will go dark. But science evolves. The James Webb Space Telescope and other cutting-edge instruments are already changing what we know. Every time we peer deeper into space, we re-look back in time, seeing the echoes of the universe's beginning and maybe its end. Some physicists believe clues to the true nature of dark energy, vacuum states, or even alternate dimensions could be hidden in the cosmic microwave background, the faint afterglow of the Big Bang. Others suggest we may one day learn to detect a vacuum bubble before it reaches us, though if it moves faster than light, it might not matter. Still, this isn't just theoretical. These are real possibilities based on the best science we have. The universe we live in, this beautiful, complex web of galaxies, stars, and life, is temporary. It had a beginning, and it will have an end. The question isn't if, but how. And maybe, just maybe, there's a strange kind of comfort in knowing this. We read part of a story far bigger than ourselves, a cosmic journey billions of years in the making. And while the end may be cold, chaotic, or sudden. It reminds us of how rare and precious this moment is. We exist between the beginning and the end, between light and darkness, between everything and nothing. We're lucky to be here, to look up at the stars, to wonder, to ask questions like this. So, the next time you stare into the night sky and feel small, remember, you're part of the universe trying to understand itself. And while we may never control how it ends, we do get to choose how we live before it does. And that, in a universe full of uncertainty, is something worth holding on to. We've already seen the terrifying theories: heat death, Big Rip, Big Crunch, and vacuum decay. But the end of the universe isn't just a story of destruction. It's also a story of transformation. What happens after the stars die out? What if the universe doesn't end in silence, but evolves into something stranger? To understand that, we need to go even deeper. Not just into the death of matter, but into what reality itself might become once the curtain falls. Let's return to the idea of heat death. In this scenario, everything eventually reaches thermodynamic equilibrium, where all usable energy has been spent. No light, no heat, no motion. The temperature of the universe levels out to just above absolute zero. Over the next 100 trillion years, stars will run out of fuel and die. Most of them will collapse into white dwarfs, neutron stars, or black holes. But even those won't last forever. White dwarfs will fade into black dwarfs, emitting no light. Neutron stars may drift alone in the dark. Black holes will dominate this phase of cosmic history, the so-called black hole era. They'll pull in whatever matter remains. But even they aren't eternal. Thanks to Stephen Hawking, we know that black holes emit a tiny amount of radiation, Hawking radiation, and over unimaginable timescales they'll evaporate. The largest black holes might take 10 years to vanish. That's a number so large, it makes the age of the universe 13.8 billion years look like a blink. And when the last black hole evaporates, that's it. The universe enters what scientists call the dark era. No planets, no black holes, just particles, a few stray photons, maybe some electrons floating through cold, empty space. All structure is gone. Time still ticks forward, but nothing happens. It's the ultimate quiet, not death in the dramatic sense, but something more existential. The universe still exists, but it's empty. In every way, that matters. But what if there's something after that? Some cosmologists think the universe might not be completely dead, even then. In fact, there are speculative ideas, rooted in quantum mechanics and the nature of entropy, that suggest the story might not be over. One idea is the recurrence theorem, which says that in an infinite amount of time, any finite system will eventually return to a state very close to its original configuration. Translated into cosmic terms, it means that, theoretically, the universe could spontaneously reset, randomly fluctuate into a new Big Bang. But here's the twist. In such an event, you could also randomly fluctuate into existence. You, sitting there, thinking, watching this video, could emerge as a temporary quantum blip in a dead universe. Scientists call this a Boltzmann brain, a self-aware structure that forms due to sheer random chance. It's wildly improbable, but not impossible over infinite time. And if that's true, it raises disturbing questions about what's real. Are we living in the original universe, or are we the dream of a dying cosmos? As bizarre as it sounds, this is the kind of thinking modern physics leads to when you push it far enough. Because at the edge of everything we know lies uncertainty. And even paradox. That's where multiverse theories come in. Some physicists believe that what we call the universe is just one bubble in a much larger cosmic foam. A multiverse, each bubble could have its own laws of physics, its own beginning and end. In this view, the end of our universe, isn't the end of everything. It's just a local event. And there's more. One idea is that our universe could give birth to new ones. This is called cosmic inflation, and some versions of the theory suggest that inflation never really stops. It just keeps bubbling off new universes. Some might be like ours. Others might be wildly different. Maybe even some that allow new forms of life, time, or matter. In this scenario, the end of our universe is just part of a never-ending chain reaction. A universe producing universes. Now, let's talk about information. You might think that when a star explodes or a black hole forms, all the information about what once existed is destroyed. But physics doesn't like that. One of the fundamental rules of quantum mechanics is that information can be erased, only transformed. This is known as the information paradox, and it's still one of the biggest mysteries in theoretical physics. Some researchers believe that information gets imprinted on the event horizon of black holes, the boundary beyond which nothing can escape. When the black hole evaporates, the information might be encoded in the Hawking radiation itself. If that's true, then the final death of the universe might not be a disappearance, but a memory, a cosmic record written in the language of entropy, waiting to be decoded. But let's pull back for a moment. With all this talk of trillions and quadrillions of years, It's easy to feel disconnected. These are timescales beyond comprehension. And yet, we live in a unique moment, a universe still full of stars, of galaxies, of life. A universe where energy still flows, where entropy hasn't yet won. We are incredibly lucky to be conscious in this sliver of time. Statistically speaking, the odds of being born during the brief phase when the universe is habitable are astonishingly small. But here we are. So what do we do with this knowledge? Knowing that the universe will end slowly or suddenly can be frightening, but it can also be freeing. It reminds us that nothing lasts forever, that we are part of a grand, unfolding cosmic narrative, that even as everything fades, the act of witnessing, of understanding, of wondering, that matters. Because in the end, the universe doesn't care if we exist. The laws of physics don't change because we ask them to, but that makes our presence even more extraordinary. For a brief moment in the life of the cosmos, there is thought, there is beauty, there is curiosity, and perhaps that's what gives the universe its meaning. Not its beginning or its end, but the fact that in the middle, for a time, there were beings who asked why. So yes, the universe is ending, slowly, inevitably, silently. But until that day comes, we are the voice of the cosmos, the storytellers, the explorers, and maybe, just maybe, the ones who will carry the light a little farther before it fades. Maybe the end isn't something to fear, but something to witness, and in doing so, to become eternal in our own way.